Today we're going to begin looking at inspection analysis. And in inspection analysis, what we're going to do is try and simplify the analysis of our transistor circuits by recognizing simple patterns in the circuits. So when we do inspection analysis, we're always going to have to do the first thing, which is find the DC operating point. And this is all DC currents and voltages. From these currents and voltages, we can determine the small signal parameters of the transistors that we're going to be analyzing. So for instance, we're going to be looking for the GMs, the R-Pis, the R-outs of the transistor, and we're going to use these, of course, to plug into some well-known formulas. Once we have the GMs, R-Pis, and ROs, we're going to convert our circuit to small signal. And what this means is that any DC voltage source becomes a short circuit. Any DC current source becomes an open circuit, and big capacitors become short circuits because they have low impedance at almost any frequency. And then we're going to analyze the network based on prior experience. So what we're going to try and do is learn the different types of amplifier topologies that we have. We only have 3 topologies for a MOS transistor and 3 topologies for a bipolar transistor, so we can easily put this on a formula sheet. Now, in general, voltage amplifier gain is given by the following formula: big GM times big RT. What big GM is the total transconductance of the circuit. And what this really means is that we're going to include the effects of all resistors and biasing circuitry and the like. So we're going to include the effects not only of the transistor, but of the things that we connect to the transistor. The RT is the total resistance at the output node. Okay, so knowing these couple of things, we can define GM as the change in the output current due to a change in the input voltage for the circuit. And I shouldn't use capital letters. This is small signal analysis, so it should be the change in the output current divided by the change in the input voltage when the output voltage is equal to 0. In other words, we put a short circuit at the output. For the total resistance of the circuit, we're going to define this as the change in voltage at the output due to a change in current at the output when the input current is equal to 0. In other words, we leave the input open circuited and we measure the change in voltage at the output due to a change in current at the input. Okay, we're going to look at this a little bit more detail in the next set of slides.